Hello and welcome back to a new video. And as always, I want to thank all the nice people that support this channel on Steady. The topic for today is functional analysis, because this is the one most of you voted for. Therefore now I have a whole series planned to get into the real interesting stuff concerning functional analysis. What you should know is that functional analysis is a really wide field. However, to get an idea what it is about, you can just look at these two blocks. On the one side you have the linear algebra, and on the other side you have the real or complex analysis. In a rough sense, if you look at infinite dimensional spaces in the linear algebra sense, and if you want to apply some analysis for these spaces, then you are in the realm of functional analysis. Of course, there's much more to it, but if you have some knowledge in linear algebra and analysis, now you know what to expect. For example, here we consider spaces consisting of functions or of sequences, and of course also linear maps between such spaces. Because in this field we always combine algebraic structures with analytic properties, one often summarizes functional analysis just by saying it's the study of topological algebraic structures. Don't worry, what this exactly means we will clear up in the next videos. However, what you should see here is that topology plays a role here, and indeed it's not a bad idea to start with topology when dealing with functional analysis. However, that's not what I want to do here, because I want to start with something that is closer to a normal analysis course. And that is the structure we call a metric space. A so-called metric space is not at all complicated. We start with a set X and we visualize that as a collection of points. For example, in the set X we have a lowercase point x, so just an element in our set, and another element we can call y. If we just consider a set, we can't say anything about these points other than they are equal or not. So there are different points, but we don't know anything more than that. Now this is what we now want to change. We want to give the set X more structure. In this case we want to know what the distance between two chosen points is. Now if we want such a distance, then of course it should fulfill some reasonable properties. For example, if we choose two distinct points, then the distance should be always positive. Of course, the distance could also be 0, but only in the case when x and y are the same point. In order to formalize that, we have to write down a map. This map is called a metric and it measures distances. And now it gets 2 points, so it lives on the Cartesian product of x with x. And it maps into the non-negative real numbers. So 0, infinity, where 0 is included. Now, such a map we call a metric if it fulfills 3 properties. And the first one we already know. If the distance between 2 points is exactly 0, then this is only if and only the case if x is equal to y. The second property is also very descriptive. So if we look again at 2 points, x and y, and now we measure the distance from x to y. And of course, this should be the same as starting by y and going to x. So the distance from y to x should be the same as the distance from x to y. This means for the map, it is symmetric. It does not matter which is the first and which is the second element. You get the same result. And now the last property is very important. It is called the triangle inequality. The name already tells you, now we consider 3 points instead of 2. So there's a point z. Now we have a distance from x to z and also distance from z to y. Now the triangle inequality tells you, if you go a detour, then your distance gets longer. In other words, if you add the gray lengths, then it gets longer than the blue line here. In a formal way, this means d of xy, the blue line, is less or equal than distance x to z plus distance z to y. Now with such a map, we can now measure all the distances in a set X. Therefore, we call the set X with the metric D a metric space. And you already know, if we can measure distances, we can do a lot of analytical stuff. And this is what we will do in the next videos. So please use the comments to tell me what you want to see in the functional analysis course. So thanks for listening, and hopefully I see you in the next videos. Bye!